In this chapter, we start learning about these things called quadratic functions. And quadratic functions are functions that you'll be graphing for many years to come. So we're going to go through this chapter in pieces. I'm going to introduce all the different parts to you gradually so you really have a true understanding of quadratics. Quadratics are nonlinear. They're written in the form y equals ax squared plus bx plus c, which for quadratic functions means that it's raised to the second power, so you definitely have that exponent there. And like I said, I'll introduce what the a, b, and c represent. The U-shaped graph is called a parabola. The lowest or highest point is called the vertex, and the line that splits it into two equal parts is called the axis of symmetry. So what we're going to start off doing in example 1 is just identifying the different parts of the quadratic function. So first thing that they want us to look for is the vertex. Remember, the vertex is either lowest or the highest point, and there'll only be one. So in a quadratic. So we have this point right here, that's our lowest point. So the coordinates of that are 2, -3. The axis of symmetry, once you've found the vertex, the axis of symmetry goes right through the vertex. So that's the line x equals 2. The domain is the set of real numbers because we can plug in anything we want. And for the range, it's all real numbers, but you have to be but y has to be greater or equal to -3. If you want to try example B on your own, go for it. If not, follow along with me. The vertex is up here at the highest point. That's the coordinates -3, 7. The axis of symmetry goes right through that. And the axis of symmetry is going to be x equals -3. The domain is all real numbers because there's no x value that I can't plug in. And the range is all real numbers, but y has to be less than or equal to 7. All right, in the next example, we're going to do some graphing. So they want us to graph the function y equals x squared. And remember, I told you that anytime you don't know what a graph looks like, you just make a table of values. That's always the default way of graphing a line. Obviously, it takes a little longer if you don't know like a fancy shortcut, but it gets the job done. So if x is -2, then when I plug it in, y is 4 because -2 squared is +4. When I square -1, I get +1. 0 gives me 0. 1 squared is 1. And 2 squared is 4. So I just took these values here and plugged them into my function for x. So now I plot the points. So pause the video, plot your points, and then play. Now, just like when we did our exponentials, you want to connect them without a ruler using a freehand and just connect them using a smooth curve, and it'll end up making a U shape. And we want to label our graph y equals x squared. I'd like you to try letter B. It's asking you to graph something, but before you graph it, you have to obviously finish the table of values. You know what? I'll fill in the table of values with you, and then you'll go and graph it and finish the question on your own. So let's plug in. Order of operations said that when we plug x in, we have to square it first, and then we'll multiply by 2. So -2 squared is 4, and 4 times 2 is 8. -1 plugged in is -1 squared, which is +1. And +1 times 2 is 2. 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. And 2 squared is 4 times 2 is 8. So plot the points and make your U-shaped graph. You have to describe the domain and range, and then you also have to give me a sentence about how it compares to the graph of what we just did, y equals x squared. So pause the video, and when you're ready, play to see how it matches what I have. All right, so let me explain a couple of things that I want to point out. I put both graphs on the grid so that I could truly compare them easily, because they both seem to make that U shape, so I wanted to see more specifically how they were related. So I brought y equals x squared down, and I saw that when I put the new one, 2x squared, on the same graph as x squared, it was narrower than the original. So that's where I came up with that. Hopefully your domain and range match mine. What I would like to make sure you understand is that the standard graph is y equals x squared. When you have a fraction in front of x squared, when a is less than 1, but still positive, then it gets wider. And when a is greater than 1, it gets narrower. So you, knowing that, you can know right away that 2x squared is going to be narrower or skinnier or whatever you want to call it compared to the original. If it was y equals, let's say, 1/2 x squared, it would have opened wider than the original. The fractions make it wider. It makes their slope not as sharp. So you can use that idea to know whether you're on the right track for graphing. Speaking of that, why don't you try letter C? I just want to make sure you notice that I picked only multiples of 3 for the x value because the coefficient of x squared was of 1/3, and these were the only numbers that were going to give me integers. So remember, if you're picking the table, if you get to pick the numbers, pick numbers that make your life easy. So please do letter C on your own. Now we go down to letter D, and I want you to see that the coefficient of x squared, the number that's in the A spot, is negative. So you might have an idea about what that does, but let's see if it's true. So I've left it blank. I've left the chart blank for you to decide what numbers you think are going to be friendly with the -1/2, and hopefully you say multiples of 2. So since we have to pick 0, we have to do some positives and some negatives. Let's do -4, -2, 0, 2, and 4. So plug in the numbers. So this is -16 times -1/2, that's -8. This is going to be 4 times -1/2, so that's -2. This is going to be 0. This is going to be 4 times -1/2, so that's -2. And this will be 16 times -1/2, which is -8. Pause the video, plot your points. Connect it with a smooth curve, not straight lines. This is not an absolute value function with a v. This is a parabola, which is a u. And then you write the equation on the line. Final thing is to put y equals x squared on the grid to actually compare. So you can see that the negative actually flipped it down, so it's facing the other direction of that y equals x squared. So if this graph is considered opening upward, this graph is considered opening downward. Additionally, it is wider. I guess I should make that a complete sentence. It opens downward and is wider than y equals x squared. You don't have to get specific about how the width changed. Like, you don't have to say it is 1.5 times wider. You just have to recognize that it's getting wider. Oh, one more thing that we have to do is to find the domain and range like it says up here. So first thing is the domain. And the domain, as for most of our parabolas, is real numbers. And like I said, you will get ones in upcoming math courses that do not have a domain of real numbers, but for now in the basic level, that's what we have. And when we go to the range, we're looking at our y values of the of the black graph. And our y values have 0 as their maximum. So it's all real numbers, but y is less than or equal to 0. Final summary thing we want to do is to think about how the value of a changes the graph. So if you notice when we had an integer, or at least a number greater than 1, it made the graph narrower. When we had a fraction, it made the graph wider. And when we had a negative value of a, it made the graph flip downward. So let's put those things in. So here are the 3 different categories. If you're greater than 1, you're narrower than x squared. If you are between 0 and 1, meaning a fraction, but still positive, you're going to get wider. And if you're less than 0, then you're going to go downward. And if obviously you're less than 0 and integer or larger, it's going to be narrow and down. If it's a fraction that's less than 0, it's going to be wider and down. So you could have a combination of these two, of these 3. But it's helpful to know what's going to happen to your graph, so that way if you graph something wrong, you know that there's a mistake somewhere because your graph doesn't look like what you expect it to look like. If you have any questions, write them down and ask me when you come to class.